Hello everybody, welcome to today's lecture. Today we are going to do Lagrange's method of multipliers for finding the extreme values of a given function. So we understand the method of finding by an example. So let us go through the example. So suppose x, y are connected by the relation x square plus y square is equals to 1, x square plus y square is equals to 1. Find the extreme points of the values of f of x y is equals to 7x square plus 8xy plus y square. So we need to find the extreme points of this function. So let us first try understand what we are going to do in this Lagrange's multiplier. So basically what we do is, let us name this thing to be gx, which is x square plus y square minus 1. So basically what we do is we write L of xy by fx plus lambda g y, where lambda is the Lagrangian multiplier. So after this what we do is we find Lx and we find Ly and we equate Lx is equals to 0, Ly is equals to 0. So we get two linear equations. We then solve these two equations and find the value of x and y for which these two equations are satisfied. So we get some points, say x0, y0, for different values of first we find lambda, then we go and find the stationary points. So let us try for this, and later what we do is we write dl is equals to lx dx plus ly dy, and then we find d2l, which is equals to lxx dx square plus lxy dx dy plus lyy dy square. So we check for this. If this is greater than 0, then minimum value is attained at that point, at certain point when it is greater than 0, and if it is less than 0, then maximum value is attained at that point. So this is the working formula of Lagrange's multiplier. So let us understand how we do with this example. So here what we have is fx is equals to this, and we have x square plus y square is equals to 1, which we can write as gx. So let us represent lxy, which is f of x plus lambda gx. So it will be 7x square plus 8xy plus y square plus lambda gx. So gx is x square plus y square minus 1. So we now, so where lambda is Lagrangian multiplier. Okay, so now for stationary points, what we do is we find Lx, we equate Lx is equals to 0, Ly is equals to 0. So what we get is for Lx, so differentiating with respect to x, we get 14x is x plus 8y, this is 0, plus 2 lambda x, all the others will be 0, is equals to 0, and the other one will be, let's see, so this will be 0, here we'll get 8x plus 2y plus 2 lambda y is equals to 0. So now let us check. So we can write this as 2x can be common. So if we take 2 common, it is 7 plus 2 lambda x plus 8y is equals to 0, and this will be 8x is 8x plus, and here we will have again 2 common, 1 plus lambda y is equals to 0. So this is a system of equation, so we can represent it. So we can represent it as 2 7 plus a lambda 8 8 2 1 plus lambda, and since the value of b is 0, so we can write this to be 0. Determinant will be 0. So what we get is 7 plus lambda, here we have 4 into 1 plus lambda minus 64 is equals to 0. If we take 4 common and divide it throughout, we'll get 7 plus lambda 1 plus lambda minus 16 is equals to 0. So simplifying further, what we get is lambda square plus 8 lambda minus 9 is equals to 0. So if we multiply lambda into lambda, lambda square, 1 lambda plus 7 lambda is equals to 8 lambda, and 1 plus 7 minus 16 is minus 9. So simplifying, we will get lambda is equals to minus 9 and 1 as the values. So we now go to, so now when for lambda is equals to minus 9, let us see what we have. So we'll have, if lambda is minus 9, let us see what we get. Yeah. So if lambda is minus 9, we will have 7 minus 9 is 7 minus 9 into 2x plus 8y is equals to 0. 7 minus 9 will be minus 2. So it will be minus 2 and again 4. So minus 4x plus 8y is equals to 0. Or we can say it can be x plus minus 2y is equals to 0. If we do it here in the second one, we'll have the same value. We can check it. So let's see, if lambda is equals to minus 9, we'll have 8x plus 2 into 1 minus 9y is equals to 0, which implies 8x plus, this is minus 2 into 8y is equals to 0, which implies x plus x minus 2y is equals to 0. So for lambda is equals to minus 9, we'll have these two equations as the same. And again we know that x square plus y square is equals to 1. So let us now equate this value. So from this we'll have x is equals to 2y. So let us put 2y here. So this will be 4. So here when we equate it, we'll have 4y square plus y square is equals to 1, or 5y square is equals to 1, or y square is equals to 1 by 5, or y is equals to plus minus 1 by root over 5. So if we put this value here, So we'll have x is equals to 2 into 1 by root over 5, but plus minus is there, so this is 2 by root over 5 plus minus. So hence what we get is x is equals to plus minus 2 by root over 5 and y is equals to plus minus 1 by root over 5. Similarly, for lambda is equals to 1, if we equate, we'll get 2x plus y is equals to 0. And in similar manner, if we do the same thing, we'll get x is equals to plus minus 2 by root over 5. We can calculate this, and y is equals to plus minus 1 by root over 5. It's the same thing. So now let us understand. So what we have is, we have 4 points in both the cases. So now for lambda is equals to 1, we have thus the 4 stationary points are, let us see, first both positive, so 1 by root over 5. Second we can take is first one positive, negative, and this is positive. Then we can take I'm sorry, for this thing will have the opposite case. So when we merge this, here positive and positive will get this thing, negative and negative will get this thing, then again positive, and in this case the sign will be different, say minus plus. So let us understand how this thing is coming. So for lambda is equals to 1, what we have is, we have 2x plus y is equals to 0. This implies y is equals to minus 2x, right? So we can equate this thing in x square plus y square is equals to 1, and what we get is x square plus minus 2x whole square is equals to 1, and what we get is x is square. So again we'll get 5x square is equals to 1, which implies x is equals to plus minus root over 5. But in this case what we have is y is equal to minus of 2 into plus minus 1 upon root over 5, which is minus plus 2 by root over 5. So hence, now earlier what we had was both positive, so if we match we'll get these values, right? And in this case we'll have opposite signs. So what we get is x is 1 by root over 5 and negative 2 by root over 5, and again 1 minus 1 by root over 5, and again root over 5. So these are the stationary points that we get for lambda is equals to 9 and lambda is equals to minus 9 and lambda is equals to 1. So we now find dl. So now again we go for lambda is equals to, for lambda is equals to minus 9, what we had was lx is equals to minus 4x plus 8y, and ly was 8x minus 16y, right? So we now do dl is equals to lx dx plus ly dy. This was the formula. So we now write d2l is equals to lxx dx whole square plus 2lxy dx dy plus lyy dy whole square. So we now equate. So here if we now find lxx, so partially differentiating this thing with respect to x, we'll get minus 4 dx square plus, again if we differentiate this thing or this thing with respect to y or x, we'll get, with respect to y is 8 into, and here with respect to x we'll get 8. So 8 to the 16 dx dy minus, again here if we do, so this is positive and here we'll get minus 16 dy square. Okay, so we have this thing. But what we have, since we had x square plus y square is equals to 1, so we have the relation x dx plus y dy is equals to 0. So we now try to eliminate dy in this. So how will we do that? d2l is equals to minus 4 dx square plus 16 dx is like that only, and if we put the value of dy, so see here, x dx is equals to minus y dy, or we can write minus here, and again dy is equals to minus x by y dx, right? So we can put this value here. So dy is minus x by y dx plus, again minus 16, and here we have minus x by y dx whole square. So simplifying, what we get is minus 4 dx square plus 16, so this will be again minus x by y dx square minus 16 x square by y square dx square. So we can take x square common, and I think negative also common. So negative common, we can write 4 here, and we'll get 1 minus 4x by y plus, again plus, and this is 4 x square by y square all dx square, right? So we now try to find these values, the values for which this is. So at this stationary point, let us check. At this stationary point, as we know, the stationary point for lambda is equals to minus 9 where this and this. So we find the values there. So at this, what we have, let's see. So putting the values of x and y, what we get is, we get d2l is equals to minus 4 plus, so minus 4 1 plus 4 into, so let's see, so what we get is x is 2 by root over 5 and y is 1 by root over 5. So root over 5 cancels, and we'll have 4 to the 8 here. We can write 8 directly, and here what we'll get is, this will be 4 to 6, 4 into 4, right? 16, and others will be cancelled, and we'll have dx square. So here what we get is negative of 4 into some positive quantity, and dx square will obviously positive, so this is less than 0. Similarly, we can check that if we put negative, both negative, then also we'll get the same answer, which is less than 0. Hence what we can conclude is, since this is less than 0, so we can conclude that f has maximum value at plus minus 2 by root over 5, 1 by root over 5. These 2 points fs, and where lambda is minus 9, right? So similarly we can check for lambda is equals to 1. So let us try for lambda is equals to 1. So for lambda is equals to 1, again what we'll have, Lx is equals to 16 x plus 18y, and Ly is equals to 8x plus 16y. So again we do the same method, and let's go directly to what we get. So here we get d2l is equals to 16 into 1 minus x by y plus x square by y square dx square. So here what we have the points 1 by root over 5 minus 2 by root over 5 and the other point. So at this point what we get is d2l is equals to 16 1 plus half plus 1 by 4 dx square. So this is a positive quantity and hence this is greater than 0, and similarly we can check that for the other point it is greater than 0. Hence we can say that f has minimum value at these two stationary points, which is when the lambda value is minus 1. So I hope you have an idea how we find the extreme points using Lagrange's multiplier. Now let us understand with another example. So use Lagrange's multiplier method to find the shortest distance between minus 1, 4 a point and the straight line 12x minus 5y plus 71 is equals to 0. So we need to find the shortest distance between this, right? So first let us take any point in the straight line. So let xy be any point in the straight line, right? So if we take any point in the straight line, so the distance between this point and the straight line will be given by, so we know the distance, let us denote it by this. So it will be root over x minus 1, x plus 1 whole square plus y minus 4 whole square, right? So this is the distance. So square of the distance can be written like this. So we do that thing. So let us define this to be f of xy. So this is the square of the distance and we define it by f of xy. And the condition on which it is subjected is, so this is the function. Obviously if the xy is moving, so we'll have the locus of these points and its distance obviously will increase and decrease according to x and y. So we need to find the shortest distance. That means the minimum value of x and y for which it is the shortest distance, right? So for this we construct the Lagrangian function. So we now construct the Lagrangian function, and hence what we get is L is equals to L of xy is equals to x plus 1 whole square f of x plus y minus 4 whole square plus lambda 12x minus 5y plus 71, right? We can write name is 1, where lambda is a multiplier, we know that. So again we find Lx. So Lx is equals to 2x plus 1 plus 12 lambda. I hope this is clear. And Ly is equals to 2y minus 4 minus 5 lambda, right? So for stationary points what we do is we equate this is equals to 0 and this point is equals to 0, right? So what we get is 2x plus 1 plus 12 lambda is equals to 0 and 2y minus 4 minus 5 lambda is equals to 0, right? So we have many methods in which we can do. Like previously, we can find the determinant and go on to find the values, but as we here we have the constant values, also we use cross multiplication method. So what we get is lambda by 2 is equals to x plus 1 by minus 12 y minus 4 by 5. I think you are okay with this thing, or let me explain. So we take x plus 1 as one variable and y plus minus 4 as one other variable, right? So what we have, 2 0, then 0 2, then 12 minus 5, right? And again we can write it same way, 2 0 0 2, and we don't need the third one, but let us do. So what we do is, first we keep this thing as constant for this, right? So this will be 0 minus okay, so this will be 0 minus 24, right? So let us write it here, x plus 1 whole divided by 24 minus 24. Then for y minus 4, right? So for y minus 4 we cross this, we'll get minus into minus plus 10, right? And for the last one we cross this and we'll have lambda by, so 2 into 2 is 4. So here what we see is we get all, so we can we see that we have a common multiple of 2, so we can cancel it and we get the desired result, right? So this is how we get the cross multiplication. So now, since xy is a point on the straight line, obviously this x and y are we had taken it to be point on the line, right? So we must have that, it must be a value there, right? So we put there, so we'll get 12, and let's see. So what we get is x plus 1 by minus 12 is equals to lambda by 2, right? Or x plus 1 is equals to lambda into minus 12 divided by 2, right? And again x is equals to lambda, so 6 lambda negative lambda minus 1, right? So we put that value. So this minus 1 minus 6 lambda minus 5, again we can find this value, plus 71 is equals to 0, and what we get is 169 by 2, lambda is equals to 39, or lambda is equals to 6 by 13. By simple calculation we'll get through this. So when we have the value of lambda, we can back substitute it here, and we'll get x is equals to minus 49 by 13 and y is equals to 67 by 13. So this is the stationary point. Hence what we get, the stationary point is 49 by 13 and 67 by 13, right? So this is the stationary point. So we now check that whether we get the minimum value here or the maximum value here. So for that, again we go dl is equals to lx dx plus ly dy, right? So and we had 12x plus 5 minus 5y is plus 71 is equals to 0. So what we get is 12 dx minus 5 dy is equals to 0, right? So we use these two things and we find So what we find is, so what we find is d2l is equals to lxx dx square plus 2lxy dx dy plus lyy dy square. Okay, so what we get is 2 dx whole square plus dy whole square, and which is greater than 0. By simple calculation we'll get this thing, and hence if this is greater than 0, so we have the minimum value, hence we have the shortest distance. So we need to find the shortest distance. So the shortest distance will be the distance between this point and that point. So which is root over f minimum, which is equals to root over x minus, remember, x minus 1 whole square plus y minus 4 whole square, right? So we just put the value there and we get minus 49 by 13 plus 1 whole square plus 67 by 13 minus 4 whole square, right? And so what we get is minus 49 plus 13 by 13 whole square plus 67 minus 13 into 4 by 13 whole square. Simplifying we get 3 units. So this much for Lagrange's multiplier. There is one example, I give it as a homework. It's the same thing, so I think you can pause the video and understand how it is done. So this much for today. Thank you. Thank you for watching this video. For any queries, join my group in the description, and here you can find the soft copy of the notes of the lecture and update of the next lecture. Do like and comment and share with your friends. Thank you.